Okay. So if you actually have to recap from the beginning of the course, so we started with the goal of making amplifier. We decided nonlinearity is required for making amplification, getting power amplification. So we started with the one port, then we went to a two port nonlinear network that gave rise to MOSFET. And the way we came to the structure is like this. We started with a simple common source, and then we wanted to take the difference between the two. So we decided to use a voltage buffer that gave rise to the diff amp. Then to increase the gain, what did we replace the resistor by? Current source. So basically I will say in the common source example, the resistor was replaced by a current source. Same thing happened in the differential case. And finally we saw that instead of using a separate branch to generate this bias voltage, we can do the self biasing here itself. And what was one advantage of this circuit over this? The voltage gain here you get is doubled, because you are not wasting the small signal current, you are actually reusing it here. So now what is the gain of this here? GM of which transistor? M1 or M2 times R04 parallel with. So I will say this is of the order of a GM times R0, right? Some GM times some R out of a single transistor, right? So in practice you will find that probably you can get about 20, 30 or something like that. That's the max you can get. But are you satisfied with this kind of a gain in practice? Let's say you want a gain of million. So let's see what to do, right? So let's start with this, right? Because we'll start with this and see how to increase the gain of this structure. Because once I know how to increase the gain of this structure, I can go from here to here and here to here. Correct? So let's start with this common source. So let me rewrite it. So I am drawing only the small signal circuit. So let us say this is Vi. And what was our motivation to use a PMOS transistor? Why did we go for a PMOS? What did we want to make here actually? Ideally we wanted to make a current source, so we made it using a PMOS transistor. So if I call this say M2 and M4, what is the gain here? What is the gain? Minus GM of which transistor times the output resistances. What is the output resistance here? R0 of M4 parallel to. Is that clear? Okay. So now let us say I wanted to make a current source and I used a single PMOS transistor. Seems like the output resistance of that is just R0. Now I want to make this a better current source. What do you suggest we do? You current buffer it and make a cascode. So let's try that. So let us say the NMOS side, this we have this transistor. So remember, this is the main transistor which is taking the voltage and converts that voltage to a current. Correct? So instead of having a current source now, this current source will be realized using a PMOS cascode. That is, I have the current source here, but then I use a current buffer to buffer the current. Let me draw it more neatly. So let's say this is M4, M6. So now tell me what is the gain, small signal gain. What is the short circuit GM in this circuit? It will be minus GM2. Because if I short circuit this fellow, I have GM times Vi flowing from here. The short circuit current is minus GM times Vi. So the short circuit GM is GM of M2 or minus GM of M2. What is the output resistance? What is the resistance looking up? Resistance looking up is how much? This is a cascode. Yeah, R04 plus R06 plus GM4 R04 times. How can I approximate this as? Yeah, third term is going to be much larger. Okay, is this clear? This is a cascode. I'm looking into the drain, okay, not looking into the source. So the output resistance is GM4 R04 R06. That is the resistance looking up. What is the resistance looking down? So how can you simplify this now? Yeah, I mean, I have, looking up I have a large resistance, looking down I just still have one R0. So this finally same as this. So I mean, although we increase the output resistance on the upper side, we didn't do anything on the downside, so we didn't get overall improvement. So what do you suggest we do? What can we do? Yeah, I mean, here I increase the output resistance by putting a cascode, but looking down it still have R0 of the NMOS transistor. So what do? I have to increase the resistance looking down also. I can put a cascode at the bottom side also. I mean, I have to do that, otherwise there is no gain. Okay. So let's try that. This is the PMOS side cascode. Now I already had the transistor M2, so I'll now go and put a current buffer on the NMOS side and call this maybe. Okay, so let's say if I call this M2, M4, M6 and M8. So here what do you think is a small signal gain? What is the short circuit GM here? If I short circuit this fellow, what is the short circuit current flowing? I mean, this transistor will produce GM2 times Vi. That current will eventually. So what is the short circuit GM? Minus GM2. Okay. So what is my output resistance now? Looking up, what is the output resistance? Yeah, same, but can you tell for the sake of completeness? GM6 R06 times R08 in parallel with, looking down, it is the gain of this transistor times resistance at the bottom, which is GM4 R04 times. So now we can see the gain is of the order of some GM times GM R0 times R0, correct? I mean, this GM times this. So this is of the order of GM R0 whole square. Okay. So now we obviously got a higher gain. So now this is only the single-ended picture. Now we have to make a differential version. So just like how we went from this to this to this, let's try to do the same thing. So I have gotten the single-ended version here. So what I'll do is I'll put a copy of this and make two halves and bias it with a current source at the bottom like this. Fine. So let's do that. This is the supply. I have a cascode on the PMOS. Similarly, I have a cascode for the NMOS. I'll have two copies of this. So these are connected to some bias voltages. They are small signal ground, but in practice you will connect to some bias voltages. And here I will have the bias current for biasing. Is that okay? This is the structure we saw. I have just taken two copies of this and put a current source. This is my view. So let's give some names. So this is, let us say, M1, M2, M3, M4, M5, M6, M7, M8, and here I apply the bias voltage plus the small signal, bias voltage plus small signal, and all the gates needs to be connected to a DC bias so that they are biased in saturation. So let's say I connect some VB4, VB6, and no, my job is not fully done because this is not a great thing to do, because as we saw with this circuit, we lose half the gain if we do this. So we have to generate this bias voltage and mirror the current here. So again we'll use the same logic. Here you see that what do you think will be the bias current here in this transistor? I0 by 2. So I want the same current to flow in the PMOS side also. And by the way, among M7, M5, or let us say M8 and M6, which of these two is the current source and which of the two is the buffer? Why? Yeah, remember I should have independent control on gate and source. So here I can put the gate to anywhere, source is also to VDD. So this is my actual current source. So this is my cascode. Similarly, this fellow is the NMOS cascode, and this is my diff pair. Right. So now I want to make sure the PMOS side current is equal to I0 by 2. So which transistor's gate voltage I should be changing? Yeah, M7, M8. This is my current source. So if I have to change the PMOS current and make it equal to I0 by 2, I should be basically tweaking VB8. So we can do the same thing. So let us say this is my PMOS current, this is not I0, this is IP. So let us say IP is greater than I0 by 2, correct? What can you say about this voltage Vx? Vx will increase or increase? Now if IP is greater than I0 by 2, as a corrective measure, what should I do to IP? I should reduce IP or decrease IP here? Sorry, reduce IP or increase IP? IP is greater than I0 by 2, so I should reduce IP. So if I were to reduce IP, what should I do to the bias voltage VB8? I'll say must increase VB8. So again the same logic, you want to increase this voltage is already increasing. What do you do? Yeah, the same example I give. You want pizza, your friend has pizza, you take it from your friend. This is connected to some VB6. Now it turns out this is not the only way to bias it, right? So I'll just show another variant and we'll wrap up. See here, we basically compare the current, this current and this current, correct? Now remember, I can also do the following. I can say that this current, let's say it's I0 by 2, I want to fix only this fellow, the PMOS current here. So which means I will compare current flowing here and the current flowing here, and once again I'll find that this voltage will increase or reduce based on the requirement. So we can actually short this also. I mean, just like how I made a case for comparing these two currents. Now I'm making a case for comparing this current and this entire current. And you can extend the argument again. So now you can look at, now I know that the PMOS current source current is set. So I can look at these two currents, and then I will say that I can basically go and do this to bias my M5 M6 also. You can think about it and argue, the same argument holds good. So this is another way to bias it. So if I do this, I need to generate a separate VB6. Here you are self generating. So we'll see what is the difference between these two and what are the pros and cons in the next class. And by the way, anytime you come up with something new, I always say the first thing is to give a name, and the name given to this is telescopic cascode, because apparently this looks like a telescope in some angle, I don't know.